And I've got to zoom again. And naturally it's out of focus. There we go. Okay. So how do we add these fractions together? Everybody has to know. For example, you've got 5 over 7 plus 12 over 7. That equals 17 over 7. Explained last time that a seventh is like you tear a piece of paper up into 7 pieces. Take 5 of them, and you tear up another piece, you still have 7s. And actually, you might have to tear up 2 more pieces. But you take 5 7s and add 12 7s, and you're going to have 17 of them. And this doesn't reduce, but depending on your ABC numbers and stuff, yours might or might not reduce. Okay. Need to change that angle so I can make sure we're still in focus. Okay. Okay, so here we have something a little bit, but let's say we've got 12 over 5 plus 10 over 7. Okay, well, we tear a piece of paper up into 5 pieces and another one into 7 pieces. A couple of little snake pieces or whatever. We got a bunch of fifths and a bunch of sevenths. We don't know what those add up to. However, if we break a paper up into 35 pieces, 5 times 7, then we can make up 12 fifths by just taking 84 of those 35 fifths. Okay, so maybe that makes sense and maybe it doesn't, but we want to understand fractions at that level. Okay, now the operation is simple enough to take 12 over 7 over 5, and we multiply by 7 over 7, and we get 84 35ths. So we tear paper up into 35 pieces. Every 7 of those pieces makes a fifth. Again, yeah, maybe think about that a little bit, but here's the operation. I think everybody did pretty well. I didn't look at everybody's paper. Now, when I multiply by 7 over 7, I'm multiplying by 1. When I multiply by 5 over 5, I'm multiplying by 1. So this is still equal to 12 fifths. But it's going to look different. It's actually 84 over 35. And if I did that right, if you reduce this, it will reduce down to 12 fifths. Because again, you multiply by 1. Okay, 10 over 7 times 5 over 5 is 50 over 35. So this adds up to 134 over 35. That's not going to reduce because 35 is a multiple of 5 and 7. 134 is not a multiple of 5, and it's not a multiple of 7. 7 times 20 is 140. Subtract 7, you get 133. As 133, you can knock out 7. It's not going to work. Okay. A times B squared. I don't think I saw anybody having a problem with this. That's 5 times. If B is 7. And that would be 245. Doing the arithmetic right. Okay. Now, a lot of people will see an expression like this and first multiply these and then square it. It's not the way the order of operation works. You do exponents before you do multiplication. And you have an assignment. You've already done, if you've done everything, I've already done an assignment, order of operations with fractions. Okay. There's another one. It's due like maybe tomorrow. Order of operations. Okay. Or anything. Yeah. you do the order of operations of fractions, you can do the order of operations of everything anyhow. Okay. When we do this one, it's easy enough. That's 5 times, let's say 7, and we use the C again. Making it easy on myself with the 10 there. So you multiply that out. That's 5 times 70, which equals 150. Again, people don't appear to have had too much trouble with this. Okay. Okay, now we get down to percent. And as I've said, you put a calculator in your hand with a percent button and nobody knows what percent means. Terrible, terrible, because it's an intuitive idea we really need to build on. You know, the fact that people come out of our secondary schools not knowing what a percent is with no concept of percent, just a button on the calculator. And that's not universal. Some people have a very good sense of what a percent is, okay? But most people don't. Most people who come into a pre-calculus course don't. So what's 8% of G? Well, let's say that's 5% of 26. Okay. Yeah, there's nothing to go to your calculator and press buttons. You need to press buttons, convert this to a simple multiplication. Then it's legitimate to press the button. Okay. Although 5% of 23 is what we should be able to do without pressing buttons. Okay, so 5% means what? 5% means 5 per 100. Okay. So I'm going to put this in red. Or 5 over 100. Okay. So I'm going to do it with fractions to kind of emphasize in fractions. Of course, you know, you can express that as 0.05. And that's now equal to. So let's do it both ways. 5 over 100 times 23. Now, since we're multiplying fractions, just to remind ourselves we multiply numerators and multiply denominators. We express 23 as 23 over 1. And that gives us 115 over 100. We should know how to divide by 100. We get 1.15. Or we could write this as 0.05 times 23, which is 115, but we move the decimal over 2 places. You get this. Okay. So again, I urge you to focus on what things mean, because you understand what everything means, it's easier to build on. And you need to build quite a bit. Here through pre-calculus, you got to do a lot of building. Okay. Now, pause a minute and see if we got any questions. Another example. 4% of 9. That's what somebody got to ask about it. 4 over 100 times 9 over 1, which is exactly what we have, which is 36 over 100. And then dividing by 100, you take your 36, and the decimal's like here. You move the decimal over 2 places because you're dividing by 100. It's got 2 zeros. And it's entirely possible that you've lost track Some of you have lost track of how you divide by a power of 10. Okay. That's something you want to maybe look at or go to Mark and let them look through that. Okay, I would recommend maybe Googling how to divide by 100, how to divide by 1,000. And it'll take you to things. Okay, very simple rule. But again, in the calculator era, it's one that not everybody's going to remember, because people use calculators when they shouldn't. And they're encouraged to do that so that it can appear that you know something you don't. Okay. So it's a very easy rule, very easy rule. Okay, I'm going to talk about linear equations. Something people in this course typically do better, as I think I've said, than they do with elementary arithmetic, with fractions, percents. That's because you've probably been required to do it without a calculator doing it for you. Okay, well, let's just take an example. I'm going to ask you to work through this. I'll just kind of figure. I'll give you a few examples. And I'm just going to use plain old numbers right now instead of the A's, B's, and C's. But you can expect to come in Monday and have a quiz with the A's, B's, and C's. Okay. Same stuff. Usually on. Okay, so let's just take pretty simple one. 5x equals 45. So I want you to solve that equation, showing me the steps as you understand, so I can see what you do and don't understand, so I don't have to talk a lot about what you don't understand. I can, what you do understand, I can focus on what you don't, if there's anything you don't understand. Okay, so let's now say we got put one in here. Those four. Okay. So let's just solve these and make sure we understand the rules. Okay. We have 5x equals 45. Well, one rule says we can divide both sides of the equation by the same quantity. So I can do 5x divided by 5 equals 45 divided by 5. Okay. Now, people will want to cross out the 5s. I don't like that because people cross things out wrong. I mean, there's an epidemic of it. Okay. If it was a dangerous virus, it would wipe out civilization. Okay. So to understand why 5x over 5 is equal to x, you just write it out. Five over 5 times x over 1 equals 45 over 5. Okay, we know that this is equal to this because if you multiply the numerators, you get 5x. If you multiply the denominators, you get 5. Now, 5 over 5 is just 1. And I do trust you to understand that x divided by 1 is x, and 1 times x is x. Okay, so multiplying by dollars once just leaves you x. And now I'll finally divide 5 into 5. Good question. So, well, if I know that 5/5 is 1, of course you know that, can I just write X without crossing stuff out? And my answer was, if I ask you to break this down and show me why 5x over 5 equals X, you want to show me these steps. Okay. If not, you could say, you could write, okay, let's say 5x equals 45. And you show me 5x over 5 equals 45 over 5. So that X equals 9. So 5/5 equals 1. Okay. As long as you're not making mistakes, I'll accept that. Again, though, if I ask you specifically, why is 5x over 5 equal to X? You can't say because 5/5 equals 1. You have to say because we can write it this way and now use 5/5 equals 1. And then all these multiplications, division by 1 gives X. Actually, a couple of steps we could write out there, but I don't want to get even more ridiculous. Okay. Okay. So now we got 5x minus 7 equals 32. What are we going to do with this? There's a temptation to write strong. Okay. What's wrong with that? You can't select what you divide by 5 on a side. You have to divide the whole side by 5. And right there, we're being selective. Because you know you want to divide the 5x by 5, so it's pretty natural to just forget that you also have to divide that 7 by 5. Okay? So that would mislead you. And I saw something like that on the second page, which maybe not on this problem, but no. Make sure we understand the rule is divide both sides. And I'm going to write this like so: 5x minus 7 over 5 equals 32 over 5. Okay. Then you can say, well, okay, 5x minus 7 over 5, you have a distributive law. Okay, and I'll explain a little more about the distributive law with a more obvious example, but multiplication or subtraction, well, multiplication distributes over addition or subtraction. Okay, actually we say distributes over addition. Some technicalities, we don't worry about that. This is like multiplying 1/5 by the quantity 5x minus 7. Meaning you'd have to multiply the 1/5 by 5x and the 1/5 by the negative 7. And that comes out what's up. Now I'm going to write more steps than usually necessary. You know, most of you have been taught not taught to write it out in this form. Okay. You've been taught to say, well, we got this, and then we add 7 over 5 equals 7 over 5. Okay. That's okay. But I usually write things out like this because you don't have to write as many lines. More efficient with board space, and it's more efficient on paper. So you take this and you add these, and it gives you, of course, negative 7/5 and plus 7/5 is 0. It gives you 39 over 5. Okay. So that's a way we're used to writing it out. This is the way I'm going to write it out. I just append the addition of 7/5 on both sides of the equation. It's got to go on both sides. Again, this is equally valid, just takes up more space in the table. Okay, and you're going to see it this way. You're used to seeing it this way. So I want you to be able to see it this way because you will see textbooks and so forth where they write it out this way. Okay, now I'm writing it out this way because I want to emphasize dividing both sides by the same thing. There's a more efficient way to do it, and we'll do that in a minute. If somebody had a question, so they did it this way. Said, yeah. Okay. Totally equivalent. Okay, now if we go this way, we end up with 5x over 5 equals 39 over 5. Okay. Then you kind of do this thing with the, I'll just write it out without a lot of comment. You're writing it out completely, you write this out, and then you'd have 1 times x over 1 equals 39 over 5, so x equals 39 over 5. Usually you won't need to write it out this way, but kind of in your head, think this. And again, if I ask you to write it out, be able to. Okay. Over here, if you'd done it this way, of course, you would, at this stage, you got the same thing you got here. So it doesn't matter whether you did it this way or this way. Now, the most efficient way to do this is to just add the 7 to both sides at the beginning. And usually you're going to do that. I'm illustrating the fact that there are several paths you can take through the problem. Okay, you can add 2 equations, which is what you're doing here, to simplify the one you got. As long as both equations are true, and certainly it's true that 7/5 equals 7/5, that's fine. That's why you do that. That's why you write it out. Okay, well, anyhow. So the most efficient way, 5x minus 7 equals 32. And 7 books. Write them step out this way or this way. Then you get 5x equals 39. And then 3 dots indicating steps like this. Can we divide by 5 and simplify another thing? But that tells you that x is 39 over 5. Now visually, you see this, you say, I just move that 5 there. Okay. Well, as long as you understand how that works and think about the detail rather than just doing it out of habit and then accidentally doing it sometime when you really can't. Make sure it's valid by the rules. Because there's no rule that says you flip this over here. That's a heuristic. It's not a rule of algebra. It's something that comes from the rules of algebra. And as long as you're careful, it works. Okay. So now we get this. Now, one thing I haven't done is what I'm told we need to do. We need to check solutions. So I didn't check solutions over here because it's really easy. If x is 9, we plug that back into the original equation. It says 5 times 9 is 35. Well, from our arithmetic, and certainly I expect you to know arithmetic or single digit numbers, then it's obvious that that works. So it wouldn't even necessarily be required to write that one out, but it's still a good idea. Keep going. Okay. So we've got this equation we just solved. It starts here, it ends here. Well, we check. Okay, the chap. X is 39/5. We plug that back in here. That gives us the equation 5 times 39/5 minus 7 equals 32. Well, we multiply 5 times 39/5, 5/1 times 39/5 minus 7 equals 32. That gives us 5/5 times 39/1 minus 7 equals 32. This is 1. Get 39 minus 7 equals 32. Finally, it says 32 equals 32. Okay. Again, you can kind of skip these steps, but be aware of them. Okay, so we just go directly from, well, that is going to give us a 5/5 and 39/1. So it's going to give us 39. You do that in your head. You can see that, and you know that that's connected. I mean, it's directly one of the rules of arithmetic. Okay. Point is, it ends up giving us an identity 32 equals 32. Okay. All the technical details there. I'm really trying to focus you on the rules rather than on habit. Because a lot of people come into these courses with their own habits. They apply habits that work sometimes to situations that don't. You want to be able to check it against the actual. Okay. Third equation. Now here's where we get to the distributive law. I kind of talked about it a little. Here's where we really want to use it. Okay, well, 5 times x plus 6 is 5 times x plus 5 times 6. That's probably familiar. The rule says that a times b plus c equals ab plus ac. A lot of people will write this like so. Pretty universal, I used to do it. But I knew the rules really well. So I could always justify it when it gets into something more complicated. Like if I've got a plus b plus c multiplied by a plus c plus d plus e. Okay, how does it come out there? We can still kind of do this thing, but we want to break it down with the distributive law so that we really understand the law. And this is the law. This is kind of the way the law feels. Make sure you understand the law. Okay, well, there's the law. So you get 5x plus 30 equals negative 15. Well, then 5x minus 30 is negative 15 minus 30. 30 minus 30 is 0. Eventually, you'd have to write plus 0 in a step and then go on. That's one of those steps that you can skip. And pretty much apply. So we got 5x equals minus 45, and 5x over 5 equals negative 45 over 5. And if you want to do this, it's okay. Right. Since 5 over 5 is 1. And again, I'll repeat it for the 45th time. I ask you to show me how you get from here to here, from 5x over 5 to x. Sure, you can do it. Not going to fail the course if you don't, but you're probably going to later on make mistakes that don't cause you to fail the course. Okay, but that will trouble you the rest of your life. Okay, so we're trying to avoid those. Okay. Now, the big message here is do the mathematics by the rules. Make sure you know how the rules apply so you don't do something that looks like it's right and isn't. Okay, we get down to this one. Well, if you know the distributive law, And there's an extra step in this one, and we got to see that step. But it's pretty easy to put this into a form that's not difficult to deal with. So let's take it for the quantity x plus 3 equals 6 times the quantity x minus 5. We're using the distributive law. That's 4x plus 4 times 3 equals 6x minus 6 times 5. Then with the multiplication, you get this. And I recommend right now you write out this step. I mean, you can do it in your head. 4x and 4 times 3 is 12. You get directly from here to here. You get directly from here to here. And what you reinforce the distributive law. Okay. So that's a recommendation. I'd like to see when I quiz you in this next thing. And all I'm going to do is give you some more instructions like these. Maybe a little more complicated, but if you have the distributive law and understand everything we've done here, you pretty much got it until you see a disguised linear equation. I'll give you an example of that just to show you what you can watch out for later. Okay, so here we have this. Okay, so we have then, what are we going to do? Well, I want the numbers over on this side and the x's on this side. Now I could put the x's on this side and the numbers on this side and be equally valid. But I want to get the thing, ultimately, I want to get the equation into a form, well, into a form like this. Some multiple of x equals some number, then we absolutely certainly know what to do. We do that by adding and subtracting or subtracting equal quantities from both sides. So we get 4x plus 12 minus 12 equals 6x minus 30 minus 12. That's going to result in no pure numbers on this side, just multiples of x. That's going to give us 4x equals 6x minus 42. Now we still aren't in a form like this. We're just a multiple of x equals some number. So we subtract 6x from both sides. 4x times 6x equals 6x minus 42 minus 6x. 4x minus 6x is negative 2x. That's equal to negative 42. Then we divide both sides. Three dots indicating, make sure you understand the steps to go from this to x. So we get x equals 21. Then what do we do? Yeah. We bring that value of x up here and replace all the x's by 21. Then we get 4 times 21 plus 3 equals 6 times 21 minus 5. And that's 4 times 24 equals 6 times 16. And 4 times 24 is 96. And 6 times 16 is 96. This checks. Okay, I'm going to take the time. We've got a few minutes. I'm going to show you a couple of places where you kind of get curveballs. Okay, I've got a curveball. My chalk is disappearing. Thank you. You think on a black table I'd be able to find white chalk. There's so much white paper. Uh, Maybe I made it short, maybe I wrote too much. Okay, before I show you a couple of curveballs that can occur, and make a couple more points about equation solving. I'll tell you, you have a, you might not have. Give me a second, I can check real quickly. No, you don't, never mind, okay. So what I was about to say doesn't apply in this course. Let's take another equation. How about 5 over x plus 6 equals 12? Okay. Now, what in the world are you going to do with an equation like that? If anybody has an idea, raise your hand and we'll pause the video and you can tell me what your idea is, because I'd be interested. It's probably an equation of a type that you haven't seen much of. It's a little bit tricky, but once you understand the rules, it's not bad at all. Okay, so any suggestions? Anybody has a suggestion about what I should do first? No? Okay, so very simply, basic principle. If you have denominators, get the heck rid of them. Okay? Eliminate the denominator. By multiplication. Okay, well, all I have to do here is to multiply x. X is a denominator. Okay, if I've got a denominator, if I multiply both sides by that denominator, it's going to go away. There's x in the denominator. So we do x times 5x, 5 over x plus 6 equals x times 12. I have to multiply, if I multiply one side by x, I have to multiply the other side by x. Okay. When I do that, 12x times 5 over x is just 5. Now I'm skipping all those steps. You have your x over x times 5 over 1. But x over x times 5 over 1 is clearly equal to just 5, isn't it? X over x is 1, 5 over 1 is 5, 1 times 5 is 5. X times 6 is 6x. We have to use the distributive law. And if you're focused on getting rid of this x, it's easy to forget to multiply this one by x, okay? So be sure you write everything out carefully. Well, that equals 12x. Now that's really easy to solve. Okay? That's just like what we did over here. And subtract 5 from both sides, we get 6x equals 12x minus 5. Up here, and then we subtract 12x from both sides. And we end up with negative 6x equals negative 5. And do a couple of steps. So I'll just skip here. And that could be 5, 6, and then we. There. Yeah. So the whole thing is, once we multiply through by x, we get an equation that we know what to do with. If we know how to do this, then we can see that we subtract the 12x from both sides and get the x's over here. Subtract 5 from both sides, we get the bigger problem. Okay, so that's very straightforward. Once we get to this point, and once we're, once you've solved a few more equations and are used to it. So that's a basic heuristic that I would make note of right now because it's one that people are generally prone to forget. If you got denominators and numerators by multiplying, now you multiply both sides by the same thing. If I had a 12 over 7 here instead of a 12, then I can multiply by the x and I'd multiply by the 7. And that would get rid of the x and the 7. And we'd still get an equation that we can solve very easily. Okay. Okay, that's it. Those are questions. Okay, there was a question that when you look at that, it kind of looks like you're going to divide both sides by 12 because you got this 12x, right? So you don't want to do that until you've got the thing in the form that's like this. Okay. And since you got a 6x on this side, you don't have a multiple of x equal to numbers. So you want to work this through until you have a multiple of x equal to a number. So if you were to divide by 12 here, you complicate your life because you do back the denominators and fractions. You multiply by common denominator to wipe out the fractions, so we don't have to deal with fractional expressions. So this is much easier to deal with than what you have if you divide by 12 at this point. You'd have x, you'd have a 1/2 x over here, and you'd have 5/12 over here, and it would get messy. Stays nice and simple. Make sure that you don't start dividing by coefficients until you just got a multiple of x equal to numbers.